Talking about the unit circle, you guys are going to be able, you'll be learning how to derive the unit circle and also how to find values, how to find the trig values of the unit circle, okay? So the unit circle epitomizes everything trigonometry based, okay? Where it allows you to find the exact values, the exact sine or the exact cosine of different angles that exist out there. It is used for, it has its own, each one of these trig functions has its own graph, and the values of the graph have been derived from the unit circle. It has so many uses, and it's used throughout trigonometry and even beyond that, okay? And so today, you guys are going to basically get your first experience. Well, some of y'all, your first experience with the unit circle. Some of you guys might have done unit circle in the past, but you're also going to use it to find exact values of different angles that are on the trig functions. Some that aren't. It's not specifically stated. So, when you are dealing with the unit circle, as you can see, it is a circle that's inside the coordinate plane. Now, unlike any other point that's in the coordinate plane, it is a point that's on your unit circle. It has a radius of 1. The unit circle always has a radius of 1, which means that that diagonal line that you guys see in this picture, that you know if I were to draw a point and drop a perpendicular down from that point to create my triangle, that radius would serve as my r. Okay? And we talked the other day about, how to find your 6 different trig functions as y over r or x over r and so on and so forth, right? So when you have a point that's on your unit circle, the sine, cosine, tangent, and the reciprocals, as you guys can already see on the board, are represented like so. Sine is normally y over r, but in the unit circle, since r is 1, it's just y. Cosine is x over r, which, since, again, r is 1, is just x. Again, if you look, if it's the point xy, then you automatically know that the cosine of your angle is the x-coordinate. The sine of your angle is the y-coordinate, okay? So let's say that t is 120 degrees, okay? Well, whatever that point is, whatever that x and y point is, then you'll know exactly what is the cosine of 120 degrees, or what is the sine of 120 degrees, because it's just the x and y coordinates. From there, you can find tangent, because it's nothing but the y-coordinate divided by the x-coordinate. And then, of course, the reciprocals are just the flip of the originals. Okay? So the unit circle is a special creature that you are going to need to know for memory. You will be quizzed on this, and you will use this throughout all the trigonometry stuff that we do. Okay? So, let's derive this unit circle. All right? As you can see from the part that you cut out of your circle, the unit circle is comprised of a lot of different things. It is comprised of, what's that little symbol right there? What's that symbol? It's comprised of degrees. Okay? As you see, there's several degrees in the unit circle. But not just degrees. Its corresponding mate is what? It also has radians as well. And then these little things are called what? Coordinates, okay? Degrees, radians, and coordinates are ordered pairs. You'll need to know all those things, okay? But there's a beauty in the unit circle. There are patterns everywhere, okay? So really and truly, if you know what the first quadrant is, which is that other little piece, then you know the rest of the circle, okay? You know the rest of the circle. So what we're going to do is we're going to spend some time deriving the first quadrant of the unit circle, and then I'm going to have you use similar features to get the rest of the other quadrants inside of your unit circle. As you can see in the first quadrant of the unit circle, the degrees are already labeled for you. 0, 30, 45, 60, and 90 degrees. Okay? This particular pattern of 30, 45, 60, and 90 actually does continue for the other quadrants. They're all equally spaced in the other quadrants the exact same way. Okay? And you 30 and 45 and 60 and 90, they sound familiar, right? Haven't we talked about 30, 60, 45 somewhere else in this unit? What kind of triangles? What were they called? Huh? The special right triangles, the 30, 60, 90, and the 45, 45, 90. It comes back. Okay? It's here. Okay? So, to derive the ordered pairs, the coordinates of the unit circle, you use the fact of the special right triangles. Okay? So, let's start with the 30 degrees. And let's create a right triangle. Okay? Of course, I'm going to drop a perpendicular from the point at 30 degrees straight down to create a 90-degree angle. And so since this is the 30-degree angle, remember your angles are always formed by the hypotenuse and the x-axis. What does this angle appear at the top? 60. Okay, so this is your 30, 60, 90-degree triangle. And since this is the unit circle, what's the radius, aka hypotenuse, of this triangle? 1. Now, if you recall from 30, 60, 90-degree triangles and the makeup of them, the side across from the 30 was what in general?
Across.
It was, but like, remember the labeling of those special right triangles? Go back and look. Go back and look at 5, 1, I think.
X.
It was X. What was the side across from the 60? X square root of 3. And then what was the side across from the 90?
2x.
2x. So using the special right triangle makeup, we can actually complete the rest of the triangle for this 30 degrees. Since the hypotenuse is 1, that 1 corresponds to what?
2x.
2x. So to find the side that's across from my 30-degree angle, what do I have to do to the hypotenuse?
Set equal to 2x.
Okay, if I set equal to 2x, then that means that x is equal to what?
1/2.
1/2. The side across from the 30 is equal to 1/2. So this right here is 1/2. What about the side across from the 60? It's the x root 3. And since x is equal to what number? It's going to be 1/2 times the square root of 3. Which can be written how? Square root of 3 over 2. Actually, don't move that over. So it's going to be the square root of 3 over 2. This is coming back from the special right triangles, okay? We take half the hypotenuse to get the side across from the 30. Then we multiply that to get the square root of, multiply it by the square root of 3 to get the square root of 3 over 2. And since the ordered pairs are x and y, we know the ordered pair for 30 degrees. What's going to be the x coordinate? It's square root of 3 over 2. Because it's the distance along the x-axis that you go, which was that side, the square root of 3 over 2. And what's the y coordinate? 1/2. So the ordered pair for 30 degrees is the square root of 3 over 2, 1/2. Questions? Let's do the 45. So if I draw another triangle, that's why I'm using different colors, because it's all going to be in one. And I drop down my perpendicular from that point that's on the unit circle. This angle here is 45 degrees. This angle here is 90. So this is nothing but as another special right triangle, the 45, 45, 90. What was the makeup of the 45, 45, 90? X and X. X square root of 2. Okay. Again, this angle, or this line, my hypotenuse is inside the unit circle, so what's my radius? 1. So in a 45, 45, 90 degree triangle, that 1 corresponds to what part? The x root 2, the hypotenuse. So if I set it equal, x is going to equal what? And how'd you get square root 2 over 2? Divide by the square root of 2, and then you rationalize to get the square root 2 over 2. So x, my 2 legs, are both the square root of 2 over 2. So that means the x and y coordinate of 45 degrees is the square root of 2 over 2, square root of 2 over 2. All that stuff goes together. Probably not really. Huh? 60 is going to be the opposite of 30 because at 60 degrees, this still is a 30, 60, 90 degree triangle. It's just this time. Oh, that's great. Except this time, the 60 is the one that's down at the bottom, and then the 30 is at the top. But yet and still, if my hypotenuse is 1, the side across from my 30 is 1/2. So is the x coordinate going to be 1/2, or is the y coordinate going to be 1/2? It's going to be the x coordinate, because the side across from the 30 is half the hypotenuse, and 30 is up here. So the breakdown is that your x is 1/2, and your y is the square root of 3 over 2. And so special right triangles is used to get your ordered pairs. Now, do I expect you to use special right triangles to get the ordered pairs when I'm asking you to go? No, I'm not. But this is how it is derived. It uses the special right triangles. Okay, I'm expecting you to know those just off the gate. You know, I'll be able to say it and you'll be able to give me the response back. Okay? But if you ever forget, you can always use special right triangles to recreate it. Okay? Now, what about 0 and 90? What about 0 and 90? What about their ordered pairs? If this represents my radius, how long is this? It's 1. So the length of that is 1. Is that going to be my x coordinate or my y coordinate? It's going to be my x, because my y is what? 0. I don't go up anywhere. I don't have any height to it. So yes, my x is 0. My y is 0, my x is 1. And at 90, 0, 1, because I've gone up one whole radius, which is 1, and I haven't gone out any. There are your ordered pairs. I gave you the degrees to start with. The only thing that we're missing now is my radians. Now, you guys know how to go from degrees to radians, right? What's the formula? Pi over 180. Please do not try to convert every degree into a radian. You can do that for this one time to derive the unit circle, but after that, I'm going to need you to figure out the pattern, okay? Because you cannot spend 10, 15 minutes trying to convert all of the radians when there's clearly a pattern amongst all of them, okay? So, let's go ahead and let's get these radians in here. 0 is easy though. 0 degrees is how many radians? It's 0 radians, okay? So you can put 0 or 0 pi. It's still all the same thing. We've done 90 many a times. What's the radian for 90 degrees?
Pi over 2.
Pi over 2, okay? You know, we've done that with all the reference angle stuff and the coterm angle stuff. We've done all that. Okay? Let's get 30 out the way. 30 times pi over 180. Well, they both end in a 0, so I can cancel that out. How does 3 over 18 reduce?
5 over 6.
Oh, look at y'all. Okay, 5 over 6. What about 45? What number was in the 45? That's what was in the 180. 9. That's a little bigger. What's 45 divided by 9?
5.
And 180 divided by 9.
20.
Is there a number that can go in 5 and 20?
5. 4. 5.
5.
5. Yes.
So it's going to be what? Very nice. And the last one's 60. They both end in 0, so I can cancel those out. How does 6 over 18 reduce?
3.
Very nice. And this is the first quadrant of your unit circle. So I'm going to go back, and I'm going to go back to this big unit circle that I have, and I am going to fill in the first part, the first quadrant of my unit circle. Okay? I'm going to fill in the first part. So let's derive the rest of our unit circle. Okay? Like I said before, every other quadrant is spaced out the exact same way that the first quadrant is spaced out when it comes to the degrees and when it comes to the radians. Okay? And then if you also notice when it comes to the ordered pairs is that 30 degrees lies in the exact same spot as this point in the second quadrant. And in the second quadrant, that point is the same distance away from the x-axis as it is from the y that 30 degrees was. It's just that since you're in the second quadrant, your x's are negative. Okay? So it's the same ordered pair, it's just that the x's are negative. Okay? And that type of pattern repeats itself for the third and fourth quadrant. You just have to be careful of your signs. I've been stressing the signs. I'm stressing them some more. Okay? So, let's get the degrees in. We all know what this degree is at this point.
180.
180. Very good. Okay? Yes, that is the spacing between each of the lines. Yes. Okay? And it is also the spacing from your x-axis or from your y-axis. What's 30 degrees away from 80 going backwards?
150.
This angle is 150 degrees. What's 45 away from 180? 135. And then what's 60 away from 180?
120.
And those are the degrees of your second quadrant. Okay? It works the exact same way for the third quadrant and the exact same way from the fourth quadrant. Can you guys fill in the degrees for the third quadrant and the fourth quadrant? Third quadrant and the fourth quadrant. Once you get the degrees, you should convert each of the degrees to radians. Okay? You guys know the conversion. This is probably the only time I'm expecting you to use it to derive the radians. After this, I'm going to expect you to see if you notice a pattern. Okay? So, you should have your degrees. Now convert to get your radians for all of them. You notice how long it's taking you guys to do this? That's because, there is a pattern, okay? And my hope is that when I say that you have 4 minutes to complete this unit circle, and I hand you a blank unit circle, instead of trying to sit there and convert all the degrees to radians, because you still got the ordered pairs to do, that you'll be able to recognize the pattern and use the pattern instead and actually be very, very quick with it, okay? But let's go ahead and let's fill out the rest of the degrees. Starting from 180, what's the next one? 210. After that?
225.
To what?
35.
It's 25. 225. What's the one after that?
240.
240. And down here on the negative y-axis, it is 270. After 270? 300. 315. 330. And when you go a full circle, you've gone a full 360 degrees. Okay, let's get in these radians. These radians. After 90 degrees. What is 120 degrees as a radian?
2 pi over 3.
2 pi over 3. What about 135? 3 pi over 4. And what about 150? 5 pi over 6. Now 180 you should have already known. It's pi. Okay? Let's keep going. 210 is 7 pi over 6. 225.
5 pi over 4.
Keep going.
4 pi over 3.
3.
3 pi over 3.
And 3 pi over 2. Starting to notice any patterns maybe? Perchance? Maybe. And the thing is that I'm not going to tell you what the pattern is. Why? Because there's infinitely many not infinitely many, but there's at least 5 that I can think of when it comes to the actual radians themselves. Okay? Let's keep going. 300 degrees. 5 pi over 3. 7 pi over 4. 11 pi over 6. And you complete at a full 2 pi. Good stuff. Now, like I described about the ordered pairs are nothing but reflections over the x and over the y-axis when you're trying to go through and put in the coordinates, okay? Because 150 degrees is the same distance away that 30 degrees is from the x-axis. So that means that they too have the same ordered pair. I mean, shoot, they even lie on the same line, you guys. So yes, they have the exact same ordered pair. It's just that in the second quadrant, your x's are what? So this is going to be a negative square root 3 over 2 comma 1/2. 45 and 135 lie on the same line. But you're in the second quadrant, so it's going to be what? Square root of 2 over 2, but a positive square root of 2 over 2. And then 120 is right across from 60. They're the same distance away from the x-axis, except 120 is going to be what? Square root of 3 over 2. Beautiful. Okay? Following a similar pattern, can you guys do the second, the third, and the fourth quadrant for me, please? 180 is on the exact opposite side of 0 degrees. So they lie on the same line. It's just that since you're over here on the negative side, your 1 is going to be a negative 1. Okay? 210 lines up with 150, just like it lines up with 330, just like it lines up with 30. They basically create a box. Okay? So what's the ordered pair of 210? Negative square root of 3 over 2 and negative 1/2. Both x and y are negative in the third quadrant. What about 225? Negative square root of 2 over 2, negative square root of 2 over 2. It lines up with 135, 225 does. 240 lines up with 120. What's the order pair there? They're both negative. Awesome. 270 matches up with 90. Except now that since I'm on the negative side, it's going to be a 0, negative 1. And I continue all the way around. 300 matches up to 240. So then that's going to be 1/2. Negative square root of 3 over 2. Only your y is negative. Your x is positive. Your x is positive. So then 315 is going to be very good. And then 330 and negative 1/2, okay? Like I said, if you know the first quadrant, you know all the other ordered pairs because they just line up, okay? You just got to be careful of your sign. Everything still stays true with the whole, all students take calculus because remember, in the students quadrant, which was quadrant 2, your sign is positive. Sign corresponds to the y coordinate. And if you notice, all the y's are positive. The calculus quadrant, the fourth quadrant, the C was cosine. Cosine is x. All your x's are positive in the fourth quadrant. Okay? And so you use that to help you find the exact values of different angles, especially if they lie on the unit circle. So one thing, again, to remember is that the ordered pairs in the unit circle basically correspond to the cosine of those angles and the sine of those angles. And the sign, the negative, is important. Don't lose it. So now let's use the unit circle to find exact trig values of different angles. Okay? So we're going to find the exact value of each expression, and if it's undefined, because it could potentially be undefined, we are going to write undefined. So one of the main things to remember that you guys already have written down in your notes is that sine is equal to y. Cosine is equal to what? X. Tangent is equal to what? Y over x. And then of course you have your reciprocals, okay? So when it says to find the exact value of sine pi over 4, that means you're looking for the y coordinate at pi over 4 on your unit circle. So if you use your unit circle or know your unit circle, you go to the ordered pair at pi over 4 and you say, what's the y coordinate? You look at it and you see that that value is, and that's your answer. That is the exact value. If you try to type that into your calculator, you're going to get the decimal approximation, and that's not the exact value. That is the exact value. Okay? Cosine of 135 degrees. That means you go to 135 degrees on your unit circle, and you're looking more specifically for which coordinate? The x. So at 135 degrees, it's right here. You look at your x coordinate, and you see that it's going to be negative square root 2 over 2. Very good. Now tangent is y over x, so I'm going to use both coordinates. Okay? So I go to 270, which is down here at the bottom. What's my y coordinate of 270? It's negative 1. What's my my x coordinate? 0. Negative 1 over 0 is what? And that's exactly what you write. You see how we use the unit circle to find the exact values of these different trig expressions? Okay? Cosecant is the reciprocal of which one? Sine. So that means I basically need to flip the sign, which is technically I need to flip the y coordinate. 11 pi over 6, here it is. What's the y coordinate? Negative 1 over 2. So if I flip it, I get what? And that is the cosecant of 11 pi over 6. Do you see how? Yeah. All right. A few things that you are going to need to remember. Of course, sine is y, cosine is x, and if anything, think C comes before S in the alphabet, just like X comes before Y in the alphabet, so you don't get them mixed up. And then, of course, your unit circle. All right? We're going to practice some on our desk. Okay? We're going to practice some on our desk. Now, I don't necessarily want you to write this down, but I need you to realize this because it's going to play a part when we actually look at the graphs of these functions, is that all 6 trig functions are called periodic functions, okay? Periodic functions means that they repeat the exact same values at regular intervals, okay? You know when we were doing coterminal angles? Yeah. Remember coterminal angles?
Yes.
Oh, my Lord. Okay. So if I gave you 30 degrees and I asked you to find me another positive coterminal angle to 30 degrees, you would add 360. Technically, it would be 360 in, right? That's technically what all these are, except they're in radians. This would give me 390, okay? Now, because it has the same initial side and the same terminal side, the sine of 30 degrees is going to be the exact same thing as the sine of 390 degrees. So even though 390 is not on our unit circle, its coterminal angle is on the unit circle, which means that if we're looking for the sine or cosine or any of the trig functions of an angle that's bigger or smaller, if we can find the coterminal angle, then we can find the sine or the cosine of that value. So that's what we're going to look at next to wrap up this lesson, Okay? So I'm needing 3 more, same directions, so you don't have to rewrite them. Same directions. We're going to find the exact value of each one of these radian measures. And I picked radians because I need y'all to work with them, okay? I know you can do degrees easily. I know you can do degrees easily. So get these down. As we can see, 11 power 4 is not on the unit circle. Neither is 19 power 6 or negative 2 pi over 3. But if we can find a coterminal angle, then we can find the exact value of each. So, 11 pi over 4. Am I going to add 2 pi or subtract 2 pi to find a coterminal angle? Subtract. And 2 pi is the same thing as saying what? 8 pi over 4, because I need a same denominator. What's 11 pi minus 8 pi? 3 pi. Is 3 pi over 4 on our unit circle? Yes. So the cosine of 3 pi over 4 is going to be the cosine of 11 pi over 4. Did everybody catch that? These two are equal. So if I know what the cosine of 3 pi over 4 is, I know what the cosine of 11 pi over 4 is. Cosine is which coordinate? The x. What's the x of 3 pi over 4? So then that is the cosine of negative 11 pi over 4. You see how it works? It's incorporating a concept from the last lesson into this one. 2 lessons ago into this one. Is 19 pi over 6 on your unit circle? Am I going to add or subtract 2 pi to get the coterminal angle? Subtract. So when I subtract 2 pi, I'm actually going to subtract 12 pi over 6 because I need a common denominator. What's 19 pi minus 12 pi? So if I can find the tangent of 7 pi over 6, I can find the tangent of 19 pi over 6. So 7 pi over 6 is right here. And tangent is which coordinate over which coordinate? So I'm going to do y divided by x. 2 negatives make a. And I'm going to have to do what with the fractions? Keep, change, flip. What happens to the 2's? And when I multiply straight across, this gives me. But I got to what? I got to rationalize. So this is the square root of 3 over 3. Yes, this one was a long one. Not only did I have to find a coterminal angle, I had to keep, change, flip, and I had to rationalize. But we got the right answer. Sure did. So the tangent of 19 pi over 6 is the square root of 3 over 3. Negative 2 pi over 3. Am I going to add or subtract 2 pi? And I'm really actually going to add, because I need a common denominator. And what's negative 2 plus 6? So the sine of 4 pi over 3 is going to be the sine of negative 2 pi over 3. Sine is which coordinate? Y. So what's the y coordinate of 4 pi over 3? And that's how you do it. If the angle is not on your unit circle, you find a coterminal angle that is, and the trig function of that one is the trig function of the one that I'm asking you to find. Let's do a few on your desk, and that'll be it for the day.